So tonight, we're going to hear first from Mark Helvey. You have the bios, so I'm not going to go through all of these, but Mark is recently retired from the National Marine Fisheries Service after 30 years of distinguished service. He's worked with the Aquarium on a number of occasions, and it's good to have an old friend and colleague back. And Mark is going to tell us about Albacore Tuna Off Alaska. You've got to be kidding. Mark.
Thank you, Jerry, and good evening, everyone. Thanks for coming. You have my bio. I'm not going to go there. Let's just talk about this title. Sounds a little strange, doesn't it? How many think there are tuna off albacore tuna off Alaska? Well, you'll see that's not that strange. This is a photograph of a fisherman on a party boat out of Kodiak, Alaska, in August of 2015. Pretty good size albacore, and as it turns out, that's maybe not as unusual as we may think. So here's a distribution and spawning area of albacore in the North Pacific Ocean. There's albacore on the Atlantic, and there's albacore in the Pacific, and the Pacific has both the South Pacific and a North Pacific stock. So this stock ranges just above Puget Sound, you can see there, but every once in a while it'll venture up. Well, so the photograph of the albacore tuna by the recreational fishermen is all the way up in Kodiak. So if we're talking about climate change, that makes a lot of sense. One of the basic concepts of climate change is that a lot of species are going to be driven poleward. But could that presence off of Kodiak be related to something else? So we're going to talk about that tonight. First, let's look at marine ecosystem responses to climate change, and there are several. We can have changes in mean level of primary production. We can have changes in the structure of zooplankton communities. Ocean acidification. Catherine's going to be speaking about that following me, and I believe you had a speaker last week that talked about that. Ocean deoxygenation, productivity changes and adaptation for fish and invertebrates, and then distributional range shifts for fish and invertebrates. So we're going to there's a lot of topics when we talk about climate change and marine ecosystems, but tonight I'm going to focus on distributional shifts. So my presentation is going to be broken up into two parts. First, I'll talk about distributional shifts in fish, some of the research that's been conducted, some of the things that have been found. And then part two, I'll talk about what are the impacts to fisheries and fisheries management, and also our food security as it relates to seafood. Okay, so part one, distributional shifts in fish. So shifts in marine distribution, basic concepts. For marine fish and invertebrate species, distributional shifts may be manifested as poleward shift in the center of biomass. So seeing those albacore off Alaska makes a little sense. Expansion or contraction of the species range, and change in depth distribution. So the question is, are there other factors that may be affecting these albacore that we saw in 2015 off of Alaska? So scientists have broken down fish distribution factors into four main categories, and there's minor categories as well, but I'll just go through the top four. So fishing pressure, fishermen, commercial fishermen, and to extent recreational fishermen, putting pressure on fish populations that can cause a shift in distribution. Changes in water temperature, obviously, when we have climate change, we have warmer water, that's going to affect the fish's distribution, as most fish prefer specific temperature ranges. Food availability can also be a factor in in motivating fish to shift. And then the need for suitable spawning and nursery grounds. And I should say these factors aren't mutually exclusive. Now, in studying climate change, one of the scientific challenges is disentangling or separating some factors from one another. And I lost the title to this. This title for this slide is Disentangling Climate Change from Other Effects. And one of the effects is fishing. Impacts of fishing and climate change interact in a number of ways. So they can't be treated as separate issues. You need to look at how they interact with one another. Large-scale climatic events can also be indistinguishable from climate change. We all have heard of El Nino, El Niñas. Those are long-term events. And over a longer period, these factors become clearly separable. So now we're talking about data collection and looking at trends. So we need to use long time series of fishing activity to start at least separating out whether it's fishing pressure or if it's warmer water temperatures that are driving the fish poleward. There was a study done by several scientists in Europe. They looked at North Sea place and sole fisheries data. What was nice about that database was that it represented 94 years of data. And both species are targeted by the fishing fleets in the North Sea, and that fishing has been going on since the early 19th century. So quite a bit of pressure on these two stocks. The distribution of shift in place was attributable to climate change rather than to fishing. That's what they were able to determine. But that climate and fishing played both a role in the distribution shift of sole. So it's not all fish are going to react the same way. I went through the literature and found some more studies. These were the time series here comprise about 25 years each, 23 years. But in the North Sea study, they looked at 36 species of demersal fish, bottom type fish. 2/3 of those species shifted in mean latitude or depth, or both. Northwest Atlantic time period, 67 to 1990, they studied 36 species and 1 squid. Changes in mean latitude of occurrence for 12 of 36 species explained by variations in water temperature. And then off the coast of Norway and the archipelago, between those years, 77, 94, and 2002, they were using two data sets. They looked at blue mussel and found an expansion of its range, extended northward by 1,000 kilometers. So patterns, what I'm trying to get at with these two last slides is there's a pattern emerging that not all marine species react the same way to climate change, if it is occurring. So now let's look at fishing pressure on albacore. This histogram goes back to 1952 of the fishing pressure on North Pacific albacore. It's a highly sought after species by the Japanese fleet, the Taiwanese fleet, Korea, United States, and Canada. And you can see a little bit from Mexico. And I was only able to get this to 2011. And in 2011, the total catch by all those countries in the North Pacific Ocean was 67,000 metric tons of albacore. And then I was able to get the data from 2012 to 2016, took the average of that. That was 71,000 metric tons over that time period. So fishing pressure really has stayed about the same since 2003. So fishing pressure may not really be a factor for why we were seeing albacore off of Alaska. I also mentioned that large-scale climatic events can have effect on the movement of fish. This is a simplified conceptual view of multi-decadal fluctuations between anchovy and down here, which is a cooler water regime, and then the sardine regime, which is a warmer phase associated with water temperature. The group that did this looked back at data going back to the turn of the last century, 1900, and found that every 25 years there's approximately a shift between the dominant phase and between the two regimes. So from 1900 to 1925, we had a cool phase, so we had more anchovies. That switched in 1950 to 75 for a warm phase, which coincides a lot with, from 1925 to 1950, we had a warm phase, coincides with the Monterey sardine fisheries heyday and John Steinbeck and all that up there. So these large climatic events are occurring in the ocean. So when fish start moving, is it a response to these 25-year periods, or is it to longer-term trends in the ocean's temperature? The point here is that they're naturally occurring, and they must be taken into account when we talk about climate change. A case in point, I was able to find this on the internet. I didn't truncate it. That's how I was able to copy it. But it says albacore tuna exploration in Alaska and adjacent waters, 1949. So albacore have been showing up in Alaska periodically, at least going back to 1949 when Fish and Wildlife Service recorded that. Okay, let's switch now to food availability. As I mentioned, food availability can also be a factor in affecting fish distributions. And there are different rates of shift for species. This is one of the things that I was amazed me when I went through the literature, and that is that shifting species tend to have faster life histories than non-shifting species. So they reproduce quickly, they die young, or they die over several years. Have significantly smaller body sizes, faster maturation, and smaller sizes at maturity. Fishes with the most temperature-sensitive distributions include key prey species of non-shifting predators, so sardines. And albacore are top predators and feed opportunistically on schooling stocks, sardine, anchovy, squid, soweries. So let's look at sardines and their potential movements further north. So Pacific sardine, there was a study done by Fisheries and Oceans in Canada, and they found that Jacqueline King was the lead author. They found that Pacific sardine feeding off British Columbia are produced off the California and Mexican coast. So there's a stock of sardine that reproduce in our waters and south of us and move up each year up to British Columbia. So there are sardines that are available to the albacore further north. They found that the Pacific sardine population experiences population fluctuations, but warmer coastal waters from climate change may result in greater abundance. And the potential exists for resident populations being established off British Columbia. So the point of this slide is that there is potential prey available for albacore if they were to eventually settle further or extend their range further north. And then I also mentioned spawning areas, suitable spawning and spawning habitat You saw this slide before, but I want to concentrate on the pink area, the spawning area for albacore. So that's roughly 10 degrees north to 25 degrees north in the central and western Pacific Ocean. So the albacore spawn in that area, and then will move to the further north in their distributional range. They'll start moving to the west towards North America to feed, and that we have a really large albacore season starting in June, and it goes through about this time, maybe October. The fish will start returning back to their spawning grounds. There was not, when I was putting this together, there was not any research on albacore spawning habitat as it relates to climate change and whether that might be a factor. But albacore is a temperate tuna, meaning that it prefers cooler waters than our what we call tropical tunas like skipjack, big eye, and yellowfin tuna. Those favor more equatorial waters. So I was able to find some work that was prepared by scientists with NIMS and some other organizations on bluefin tuna. Bluefin tuna is a lot like albacore in that it's also considered a temperate species, and you do find it in northern waters. On their work, they looked at, and I just want to concentrate on the lower diagram, the triangles, but that's the spawning area, or the area where they found larval bluefin tuna that will migrate from the Atlantic into the Gulf each year to spawn. And what they speculated was that there was potential for significant impacts on spawning and migration for bluefin tuna was very high. And if spawning, and this is an if spawning is triggered by temperature, and the Gulf of Mexico waters warm earlier in the year, then spawning may commence sooner and it may finish sooner. And that may change migration routes and spawning behaviors of the bluefin. It also may require colonization of new spawning ground. So they felt that a lot of this was still speculative, but in their models, there was this potential that change in surface water temperatures was going to affect the spawning habitat of bluefin. So let's summarize the climate change effects on albacore distribution. One of the points that I made was that not all fish species display distributional shifts related to climate change. Albacore, as I mentioned, is a temperate tuna, and it prefers to feed in cooler water. So it's not unlikely that the fish could move further north as climate change continues. Fishing pressure can also play a role in fish distributions and can be particularly strong for some species. I concluded the fishing pressure looks fairly constant over the last 14, 15 years. Short time span, but that's what we had to work with, and probably not a factor for why we were seeing albacore off of Alaska. Fish size affects different sensitivities to climate change. Albacore prefer prey. Their preferred prey could establish itself further north and be available. So we talked about the sardines potentially having the ability to spawn off of British Columbia during warmer temperatures. So albacore could establish itself further north and still have a food supply. And then potential for significant impacts on spawning and migration is high. That may play a role in their in albacore productivity, but probably not yet affecting their distribution. So that's our case study of albacore. And what I wanted to do now was go into the second part of my presentation and what this means to fisheries and fisheries management and food security. So I wanted to at least inform you all about the value of U.S. fisheries. And this just comes out of the Fisheries of the USA that was just recently published. And not going to really spend any time on this, but just the value of $5.3 billion to the economy in 2016. That's a pretty high number. And then in the lower area, we see that that value, as it's distributed around the country, the Atlantic coast states, their fisheries contribute to 39% of the value of U.S. fisheries, both state managed and federally managed. 16% in the Gulf, 29% in Alaska, and then 13% of value on the Pacific, and that would also be Hawaiian Islands. So what does climate change impacts to fisheries and to fisheries management? Some species, or some fisheries and some species will increase, others will decline. That's one of the predictions by a number of scientists. I mentioned the difference between tropical tuna, such as skipjack and big-eye tuna, and temperate tuna like bluefin and albacore. And one study predicted that the skipjack population would grow by 19% in the warmer waters by 2035. And big-eye tuna, which is also tropical tuna, would increase marginally, and they didn't define what marginally meant. Fisheries and species will not necessarily respond the same way in all regions. We kind of saw that with the plaice and the sole fisheries. They responded different ways. Shifts of marine taxa may substantially affect local fishing communities. I think that should have been a verb, affect. And species may shift from one management jurisdiction to another. So these are things that, under climate change, fishery managers need to be thinking about. How do they deal with that? Are these movements in jurisdiction between states, between federal fishery management councils, or between international commissions that manage the tunas? One of the studies that the Northeast Fisheries Science Center in Woods Hole conducted on looking at climate change was to look at shifts and predict where the centers of biomass would be in 60 to 80 years. And they looked at Atlantic croaker, green, summer flounder in orange, and purple for American lobster. And so the open circles are currently where these three species, their center of biomass, the center of where is most of the stock concentrated. And they predict that in 60 to 80 years, there's going to be a shift northward, more so for the summer flounder and the Atlantic croaker than for lobster. But as you look at the map, you realize that fishermen that were in Reedville or Wanchese or Cape May are now going to be going further. So they may be, those fishing communities could be impacted. And some of the fishing communities further north might all of a sudden have new resources to be fishing. So these are things, again, that management needs to be thinking about, and fishermen and fishing communities need to be thinking about. So I worked for, as Jerry mentioned, I worked for NOAA Fisheries for 30 years. So it's really hard, even though I've been retired for 2.5 years, to forget that I'm still no longer a federal employee. So I wanted to put in a plug for what NOAA Fisheries is doing in looking at climate change and their climate science strategy. They have, these all represent the Western region, Alaska, Pacific Islands, Caribbean, Gulf of Mexico, Southeast, and Northwest. Those all represent regions that the agency works around. So there's a western region which includes all from Seattle all the way down to Long Beach. And the science centers, we have several science centers. One's in La Jolla, there's one in Seattle, and around the country. And the science centers and the regional offices in the different regions all got together. They had input from external stakeholders, and they came up with a series of regional action plans. And the whole goal of these plans is to provide decision makers, people that manage the fisheries, enough information to reduce impacts and increase the resilience of valuable marine resources and the people that depend on them. So the agency, the government is looking forward, is looking at how this may impact communities, fishermen, and how is that going to affect that $5.3 billion revenue generator that we saw for 2016. This is also being looked at on a global scale. This was a study that was done several years ago on the vulnerability of national economies from potential climate change impacts on fisheries. And the vulnerability index that was used looked at exposure, sensitivity, and the ability of adaptation, the capacity for adaptation by those fishing communities. And the yellow is very low, least vulnerable to climate change. Those countries in yellow will be able to adapt and be able to still generate income for their fishermen and have sufficient supplies of fishery resources. And the dark brown is very, very vulnerable. So we have off the Northwest South America, parts of Africa, Asia. You'll see that, you can see from that they're very vulnerable to changes in climate change to their fisheries. And then what was remarkable is up at the top, Russia and Ukraine are also very vulnerable. And part of that is, even though they have very large fishing fleets, they have a high level of exposure, and they don't have the adaptive capacity for switching to other fish species as some of the other countries. So it's just another way of looking forward as to how does the global, how does the world look at potential changes for fisheries. We import a lot of fish into the United States, and 80% of the fish that we do consume actually is imported. So that also affects these sources that would be providing imports to the United States. What is that going to do to our supply of fish? Some things to think about. And so the last item I wanted to talk about was food security, the food supply as it pertains to seafood protein. So we live in a world that population is still growing. We're undergoing climate change. So how do we provide for the world's population? And that's going to depend on climate-driven changes to the productivity of the world's oceans, obviously, and the performance of fishery management systems. So as fish shift, as fishermen shift, management needs to respond to that so that we minimize overfishing, we minimize impacts to organisms that are caught during fishing that were not targeted, what we call bycatch. There will only be modest increases in sustainable global yields for capture fisheries, commercial fisheries. As I mentioned, we're going to see a big increase, a 19% increase in skipjack tuna by 2035. That's only a prediction, but other species are not going to do as well. So how do we make up for that? Well, the need to rely on both large-scale and small-scale aquaculture can't be emphasized anymore. That it is going to be very important to all the countries' seafood security, all the world's countries' seafood security, and it's something that I think is a take-home message that we need to be thinking about. So, albacore tuna off Alaska, you got to be kidding. Maybe not. So. And that concludes my presentation. And Jerry, I think we have a lot of time for questions.
Thank you.